For most of human history, every human on Earth was dark-skinned. This fact alone surprises many people today. White skin, often thought of as ancient or original, is actually one of the newest traits in human evolution. It appeared only recently in a small part of the world under very specific environmental pressures. So how did humans become white? Was it chance? Was it climate? Was it genetics or something deeper? To understand this story, we must travel back tens of thousands of years to Africa, where humanity began. Part 1. The first humans. Modern humans, Homo sapiens, evolved in Africa roughly 300,000 years ago. Africa lies close to the equator, where sunlight is intense year-round. Ultraviolet radiation from the sun is powerful here, capable of damaging DNA, breaking down vital nutrients, and increasing the risk of disease. Early humans had already lost most of their body hair, exposing their skin directly to the sun. This created a serious survival challenge. The solution was melanin. Melanin is a natural pigment that darkens the skin and acts as a biological shield, absorbing harmful UV radiation. The more melanin the skin contains, the darker it appears, and the better it protects the body from sunlight damage. Because of this, natural selection strongly favored dark skin in early humans. For hundreds of thousands of years, dark skin was not just common, it was universal. Part 2. Why dark skin was essential. Dark skin did more than prevent sunburn. It protected something even more important: folate. Folate is a critical nutrient involved in DNA synthesis, fertility, and fetal development. Ultraviolet radiation destroys folate circulating in the blood. In regions with intense sunlight, individuals with lighter skin lost folate more quickly, leading to reduced fertility and higher birth defects. Over generations, this made lighter skin a serious disadvantage. Dark skin preserved folate levels and ensured reproductive success. In Africa's environment, light skin was selected against, while dark skin ensured survival. At this stage of history, the idea of white skin simply didn't exist. Part 3. The Great Migration. Around 60,000 to 70,000 years ago, some human populations began migrating out of Africa. They moved into the Middle East, Europe, and Asia, regions with less sunlight, longer winters, and lower UV radiation. At first, these humans still had dark skin, just like their African ancestors, but the environment had changed. Sunlight was weaker, days were shorter, winters were long and cold, and soon, a new problem emerged. Part 4. The vitamin D problem. Vitamin D is essential for strong bones, immune function, and overall health. The human body produces vitamin D when UVB rays from the sun interact with the skin. But there's a trade-off. Dark skin blocks UV radiation very effectively, which is excellent in Africa, but problematic in low-sun environments. In northern regions, dark-skinned individuals struggled to produce enough vitamin D. This led to weaker bones, compromised immune systems, and higher mortality, especially in children. In these environments, lighter skin suddenly became an advantage. Natural selection began favoring individuals with slightly less melanin, allowing more sunlight to penetrate the skin and produce vitamin D efficiently. This shift didn't happen overnight. It took thousands of generations. Part 5. Natural selection in action. Evolution does not plan ahead. It simply favors traits that improve survival and reproduction in a specific environment. In northern latitudes, dark skin equals vitamin D deficiency. Slightly lighter skin equals better health and survival. Over time, individuals with genetic mutations that reduced melanin had more surviving children. These mutations slowly spread through populations. Importantly, this process happened multiple times independently. Europeans and East Asians both evolved light skin, but through different genetic pathways. This proves that light skin was not a single ancient trait, but repeated evolutionary solution. Part 6. The genetic side of skin color. Skin color is controlled by many genes, not just one. One of the most important genes in Europeans is SLC24A5, which dramatically reduces melanin production. In East Asia, different genes, such as variations in OCA2 and MCR1, played a role. These mutations did not make humans better or worse. They simply fine-tuned the body to its environment. Genetic evidence shows that light skin became common only about 8,000 to 12,000 years ago, very recently in evolutionary terms. That means for more than 95% of human history, all humans were dark-skinned. Part 8. Agriculture changed everything. Another major factor accelerated the spread of light skin: agriculture. Before farming, humans ate diets rich in fish and animal fat, natural sources of vitamin D. But when agriculture emerged, diets shifted towards grains and plants, which contain little vitamin D. This made sunlight even more important. In farming populations living in northern regions, the pressure for lighter skin intensified. Evolution responded accordingly. Part 9. Exceptions to the rule. If sunlight is the key, why aren't all northern people extremely pale? Because diet matters. Arctic populations, such as the Inuit, traditionally consumed vitamin D-rich diets from fish and marine mammals. This reduced the need for very light skin even in low-sun environments. Skin color evolution is not about latitude alone. It's about the balance between sunlight, diet, and survival. Part 10. Skin color is not race. Here's one of the most important conclusions of modern science. Skin color is not race. It is a superficial trait controlled by a tiny fraction of our DNA. Two people with different skin colors can be genetically more similar than two people with the same skin color. All humans share more than 99.9% of their DNA. Skin color evolved as a flexible adaptation, nothing more. There is no biological hierarchy of skin tones, only adaptation. Part 11. Evolution is still happening. Human evolution has not stopped. Modern lifestyles, artificial lighting, clothing, and supplements have changed how natural selection operates. But the story of skin color remains one of the clearest examples of how environment shapes biology. Our skin tells the story of where our ancestors lived, not who we are. Conclusion. So how did humans become white? Not through superiority, not through destiny, but through adaptation. As humans moved into new environments, natural selection reshaped our bodies, slowly, quietly, and without intention. Skin color is a reminder that all humans come from the same origin, and that diversity is not division. It is survival, written on the skin.